Hi, everybody. Can you hear me well? Great. Yeah, so my name is Øyvind. I work for Architect as a consultant, the flatMap organizer. And I'm really excited to finally share this project with you. I've been working on it for quite a while. I hope you're going to like it. So today's talk is going to be about Scala.js and TypeScript. I hope that's interesting for you. So let's dig into the motivation first. No. Right. So Scala.js, I won't go into too much detail about Scala.js in itself, other than I do like it a lot, and I find it an awesome language and ecosystem with all the strong types that you would expect from Scala. It's super principled. Whenever you think it works, it works. It has a lot of really nice properties. And I do consider Scala plus Scala.js, the combination, a competitive advantage at this point. I think it works so well, especially the deep integration that you can have between the back end and the front end. I think it's really, really great. The talk is not on Scala.js today itself. And I wanted to talk a little bit about some challenges that I see. And I do have some proposal to solve some of it. So let's jump into this. And I mean, this is my perspective only. I think that although we have a lot of people working on it, we definitely could use more in terms of maintaining a whole ecosystem full of libraries, which is my second point. We have all the core libraries. We have a lot of really impressive libraries cross-compiled to Scala.js, and those are maintained because there isn't a lot of effort going into maintaining them. There is some overhead, but in terms of developer time, not so much. And browsing around GitHub, I seem to see a lot of projects without activity, and that goes especially for projects wrapping existing JavaScript libraries. And I have some theories about that too, but the theme is that it seems to be a lot of work to maintain them, and it's very tedious to maintain them. So that's what I've been looking at. So just to put this into some perspective, I just want to skip back a few years, back to the year 2012. I just want to compare how it was to adopt Scala at the top of the hype curve in 2012. We had everything going for us. It was really great. So a specific adopter would have, I think, an upwards trend where you start using the language and you find this is really cool. And then as a next step, you ask the only question that you can ask, how can I express things that I already know in my new language? So for instance, how can I use Spring with Scala? Would be something that would show up. And in those days, you would hit Stack Overflow or whatever existed in the old days. And you would get a response. Oh, just do this and this and this. Throw some @bean annotation on it, and it's good. And within 3 hours, you can produce like, oh, I have this fantastic integration library. And you would publish that. Boom. And then you would be excited by all of this and produce more stuff. Like, oh, a new library doesn't even require Spring. So we could progress from that initial compatibility layer with the host platform. And it would go on. Like, oh, here's even more shiny stuff for you, right? And I think if we compare that to the trajectory that you would see today as a new adopter of Scala.js, if you have the same enthusiasm and you ask the same question, how can I make jQuery pleasant to use? Which is not the greatest example because I think jQuery is covered, but in general, if it's another library, the result will be that you will be pointed at the Scala.js documentation that teaches you how to write facades for Scala, for JavaScript, I mean. Ugh. So the 3 hours integration job with Scala is now a 3-week project of documenting and meticulously typing up a JavaScript library. And I think it throws a lot of people off. I think it's too much effort up front. And the inevitable result is that, oh, look at this other shiny tool instead. It already has this built in, like TypeScript, for instance. So this is one of the things that I feel it was not too much work to actually solve. Okay, that was part of one of the motivation. And the second part of the motivation is just writing front-end apps in general. And this is the more egoistic motivation, and the real motivation, the first motivation I invented for the talk. So my real motivation is this, that, okay, let's say I have this amazing app written in Scala.js, and there's no JavaScript anywhere near it. We compile to it. It's a decent compile target. I'll give it that. But yeah, we at least need to acknowledge that these things are here. I could add HTML to the list, but I'm okay with HTML, surprisingly. With JavaScript and CSS, like compilation target, and I am happy if somebody else writes my styling. So there will be a point in time where I have a Scala.js app, and my designer tells me, hey, could we put an image carousel in there? And that is not something, I mean, I'm not going to shit on people who enjoy writing those things. That's a more than okay thing to do, but it's just not my expertise to write image carousels. And you would be hard pressed to find an existing Scala.js library that shows an image carousel and it will still fit in your app. It doesn't, in general, exist. So at this point, it's pretty clear that we need to adopt the host platform. That is nothing new and not controversial in a sense. I'm going to show a slide that I never ever thought I would put on the screen, but JavaScript is there and we do utilize the platform. So, I mean, there is a lot of value in embracing that. Because JavaScript is ubiquitous at this point. It's everywhere. It can open up platforms for us, phone applications, desktop applications through Electron, Node is a platform people use, Raspberry Pi, who knows? So there's a lot of stuff in that direction. There will be entire UI component libraries, and I would love to have native ones for Scala, but we don't have them yet, and it takes a lot of manpower to get there. So instead of creating ad hoc styling for your app, well, why not use something that is already done by people with dedicated designers and, well, you know, style guides and stuff. So this was my personal motivation for this whole project. I wanted material UI for my app. Yeah, there's thousands of React components that you can reuse, and it would be stupid to not tap into it. JavaScript is particularly strong when it comes to charting and graphing. Of course, we could reuse that. And then whichever integration, really. If you have a running front-end app and you just want to slap Auth0 on it to authenticate, well, there is a client SDK, and that's, of course, in JavaScript, so you want to utilize that. And just to underline how varied this ecosystem is, you can find libraries for anything. I mean, you can write the browser plugin, a Microsoft Office plugin if you want. I even saw, like, I casually browsed the list of libraries, and I saw you can write code that will run on your old Wii U Nintendo console. I mean, the possibilities here are almost endless. So that's cool. And I think if you look at this list of things, it is not something that is particularly well covered by Scala and not well served. So, well, if there is a fast-track way of supporting this, that would be really, really cool. Which brings us to TypeScript. I'm not going to go into too much detail about TypeScript itself. For this talk, we'll focus on this part of it. It's static typing for JavaScript. It has other properties that we could talk at length about because they're interesting. But the second important point for now is that TypeScript has an intense traction. It's really being used in so many libraries now, and it's gone so fast that I really think this is, for the mainstream front-end work in the future, I think TypeScript is going to be it. And for the type system geeks in the audience, I'm sure there are some. There are some incredibly cool features in TypeScript that you should look at. Type mappings, for instance, is something that I miss every day when writing Scala code now, because it's so powerful. And yeah, it's just an integration layer with JavaScript, the way I see it. So the coolest part about TypeScript is not really the language itself, but it's definitely typed. which is an enormous GitHub repo of type definitions for existing JavaScript libraries. Thousands upon thousands of type definitions, which is an incredible community effort. I don't know how many hours have been spent creating that thing, but a lot. And realistically, we could never come up with that sort of manpower for Scala. We just don't have the manpower for it. And I think the combination of this enormous traction and this definitely typed repo makes TypeScript effectively an interface language for the entire web at this point. Like, this is how all the libraries work. I don't think there's going to be any competition for that. So that brings us to my project. Right, so ScalablyTyped is primarily a compiler which takes TypeScript type definitions and translates them to Scala.js. And it's a purely mechanical translation, and it's a comprehensive translation, which means that everything that is already typed in TypeScript is something that we should be able to reuse in Scala. And I mean, I will just say up front that the conversion is still somewhat rough. You will find that being automatic between two very different languages will lead to some peculiarities in the encoding. We'll see them later. But it is working, and it would free the community from maintaining these type definitions ourselves, because it's super tedious work. I picked up the word typings from the TypeScript community. I took a liking to it, because it sounds like, to me it sounds like it has been typed after the fact, or perhaps even a diminutive of type, like a small q type or something. So for myself, I use that to describe something that is exactly the types of things, not really sugar on top of it, or what we traditionally put in facades or wrappers in Scala.js, but pure types only and references to values. So I think that's a pretty cute word. And then the goal is, I mean, just by writing that, we would enable our usage of more or less anything in JavaScript. Right, so this project exists today, and it's absolutely massive. I don't know if it's the biggest project out there, but it's certainly pretty big. So I have generated almost 7,000 libraries, and they compile and they are published to bin tray, comprising 7 million lines of Scala source code, excluding comments and new lines. It's pretty cool, isn't it? It has also picked up about more than 2 million lines of documentation. So put together, this covers almost everything in JavaScript. Mandatory warning: if any one of you goes home and try this today, I'm going to delete all the artifacts. They are snapshots at this point. So just know that it's not going to change much, probably, but the artifacts are going to be gone. And we'll probably develop the encoding for a while more. And I'll have to find some regime for publishing these artifacts in a scalable way. It's difficult. Because where do you even put 7,000 artifacts? For now, they're at bin tray. There is a lot of prior art for this. People have tried before, certainly. I want to highlight definitely Scala first, which is the processor project, I guess, for Scala.js. It was a good project. I think it's, yeah, I don't think there's any development happening there, and there's a lot of stuff that project didn't do. For example, everything that has to do with modules, and every modern library uses modules. Scala.js TS importer is Sebastian, the Scala.js author's original code base, on which mine is based, as is definitely Scala. And then there are other attempts for other languages with some degrees of success. I know at least Kotlin and C# has a story where you can use a small subset of the libraries, and they have demo projects and so on. I'm not sure about the latter two. Right, so this enormous library, it has almost 7,000 typings, and then I also made some infrastructure to write what I call facades on top. So while typings are generated 100%, a facade would be handwritten, and it will frequently be the case that whatever is generated is technically correct, but very difficult to work with because they use a lot of type tricks, which means that we can work through that by handwriting some code on top and then just utilize the generated types or whatever. You would be free to do anything. So I haven't developed this much. If you look in the repo, if I have internet, yeah. I have 4 for now, and it's really only the React one that is developed. This is something that you could use instead of, say, Slinky or Scala.js React. I wouldn't recommend it, but you could. But at least it's an example of such a facade. And this would be continuously updated with the newest generated code and published alongside everything else, which is handy. So if you decide to try something and you end up writing some glue code, feel free to pull request it. I also gathered a collection of demos. Those are mainly collected from around the internet. Like if you look at D3, the library, for instance, they will have a bunch of demos to demonstrate how you can use it. So I just stole a bunch of demos and put it into a repo and ported them to ScalablyTyped, which was, in all cases except for Angular, really simple. So yeah, that's here. It does live in its own GitHub repo. Yeah, and there's a bunch. Like if you're curious how you can do React Native with Scala.js, this is how. Well, there are some React components, Storybook. I mean, I can demo one of them. This is React and MobX, which is a brilliant state management tool, and Axios for doing HTTP calls. So it's super simple, just package up. You can have a look at the source code. I really recommend you do. So yeah, that's it. And again, if you feel like experimenting with one of the libraries, you're more than welcome to also put a request a demo, and you can live there. Right. So I am going to show some generated source code to you, but first I wanted to make a quick detour of how we actually encode these type definitions in Scala.js. So this is not specific to my project, but it's just how it's done. So for our purposes, this is the output target. So it is the case then that Scala already has a type hierarchy with any on top, nothing at the bottom, and then a bunch of types in between. So there's this parallel type hierarchy for JavaScript types that has JS any as a top type. And as soon as something extends JS any or JS object, it means that it has JavaScript semantics. So for instance, the names won't be mangled because they are important at runtime, like and calling conventions and so on will be slightly different. And you are free to cast anything into these types because there's no runtime type information for these, so any cast is valid, more or less. And there's a parallel set of function types, this function types to encode this parameter that might vary. This is also something that TypeScript does. So yeah, we have this set of types then, and we have a set of annotations. So a type definition then would be traits and objects and classes using these annotations and the types that we just saw. So there's some for encoding, where can I find this thing that you're describing? JS import specifies that it's from a module. JS global just reaches into the global scope. Yeah, I mean, these are not so important. You can just know that they're there. Right, so a super simple example is something like this. So this is Yeah, super simple definition of jQuery. It's a singleton object that is callable with a selector string, and it's going to return some structure that is jQuery. There's nothing more really. In that sense, it's pretty simple. There are some complications to the model, but that's what it looks like. Which brings us to the ScalablyTyped encoding. So yeah, I briefly mentioned this before, that the encoding, I mean, there are some things that you will see right away that this is not completely idiomatic. That's expected because TypeScript does a lot of weird things, and I essentially had to work around it. First thing we're going to see is that we use some suffixes for names, just because you can have a lot of things with the same name in TypeScript, and just to keep them from having name collisions, we add suffixes. So let's first have a look at the top level picture. What you see here is TypeScript code, and it describes a very, very small library, all invented, of course. So in this case, I just wanted to show you how things can have the same name. So we have a library called foo, which has a module here at the bottom called foo, and then at the global level, we have a namespace and a function called foo. So this namespace thing here is just, it's almost like an object in TypeScript. So it's a singleton with types, and it can have new types inside it and stuff. Interestingly, these two foos here and here would point to the same object at runtime, because this is just a TypeScript way of describing a function that has a field set on it. Nothing too interesting, but this is just how it works. So, right, I hope you can still read it. The details aren't too important either, because you would figure them out soon by yourself. But everything is put into a package called typings, and then the library here is translated into foo_lib. And then namespaces receive the ns suffix. And then we had this irritating limitation that we have a top-level function, and normally, for naive translation, you would put top-level things in the package object for the paths to just automatically translate. We can't really do that because of technicalities between inside Scala.js. I think it's going to be fixed for, well, whenever we have top-level definitions in Scala, which is going to be eventually. But for now, I had to invent a custom object for them. I didn't know what to name it, so for now, it's called this sign here. I like to call it a hat. So look inside the hat, and you'll find. So yeah, I think this conversion, like, it's more code, and it's not necessarily pretty, but this will just be the overall structure of it. I think that things are more recognizable when you look at traits and the type definitions and methods and so on. You can also notice that there's a little bit more machinery involved in computing modules. So when outputting foo_mod here, we have discovered that the two exported foos are in fact one thing, and they're exported as one object here. Yeah, nothing too special, and there's not a lot of thinking behind this. This is just I ran the compiler, and this is what came out. Okay, so another thing that you're going to notice up front, and I think it's an interesting illustration of the transformations of code that I had to do to make this compile and preserve most of the type safety, was the handling of literal types. I think it's interesting in itself, because let me show you the TypeScript code first. This is a class from Node, and it's pretty simple, but in TypeScript you can see that it's defined as two overloads, and the difference between them is first the string value here. So this really just describes one method in JavaScript. So in TypeScript they define it as two, And the interesting thing is that the type of this parameter here depends on the value of the first parameter. So if we were to translate that into Scala directly, we don't have anything else than string to put for this first event parameter. We will get literal types eventually, I think pretty soon even. But I think even then, erasure might mean that this is not possible. I'm not sure about that, but I don't think it is. So we have this very interesting encoding that is used in Scala.js for this, where we collect all the literal strings used in the library and we put it into an object by itself, and we invent types for the strings. So let's take the close string. We generate this trait. It's sealed, but that's not really important. The important thing is that it extends JS any, which means that you can cast anything to it. And here we have the string close, and we cast it to the type that we just created. And finally, we encode it such that the first parameter is one of the two types that we invented. And this way, the Scala compiler is happy to accept these two as, oh, they're overloads, but they have completely different types. You're OK to do this. And they will still point to one definition of the method at runtime. And you'll also notice that the names here contains the literal type. That's not a necessary translation, but it's something that I did to help IntelliJ out a little bit, because sometimes we could end up with hundreds of these. And IntelliJ is not really happy to have 400 overloads. So with the same name, but different types, it doesn't work that well. Surprised that I never thought about that. So yeah, just rewriting the name as well really helps IntelliJ out. Right. So in general, I think there are two difficult parts of this translation process. One was to implement a module system, because there are several module systems, and it's all very complicated, and you need to keep track of a lot of stuff. And the other was methods, because there's a lot of subtle things that it's difficult to get right. For instance, you can have a hierarchy of classes, and you can have overrides, and you can narrow the type in subclasses. So if you have a parameter that is a union of some types, and then in the subclass, it could be of fewer types, or perhaps only one. And there's a lot of complexity springing out from there. So it's difficult to talk the Scala compiler into accepting this. And, well, parameters can be optional or not. It's also somewhat normal. We're going to see it in a second, that in a superclass, a parameter can be optional, but then not in a subclass. So yeah, it's basically this. TypeScript is specifically designed to very richly describe the structures, whereas Scala has a completely different idea of what a method is, because it needs to correspond to these JVM limitations and so on. So that was an interesting challenge to take this very rich thing and rewrite it into something that feels very crude and inelegant when compared to the original. And the way that I ended up doing it, it's not necessarily something that I think it's the best in the world, but it has the amazing property that it works. So I just call that divide and conquer, because it is just me generating many methods. Let me give you an example. This is a method in JavaScript that many of you will have come across, add event listener. And if you look at it carefully, the first parameter is a string, so it's not interesting. Whereas the second here can be one out of two things. So you have this event listener blah, blah, blah object, and then null. And then the third is optional, so it can be either undefined, or Boolean, or this add event listener options. So the way I'm dividing this is that I'm just generating permutations, really. So this is one parameter, or one variation, times 2, times 3, for a total of 6. Boom. So yeah, once I did this, suddenly everything clicked and we could compile so many weird cases. So there was still some more massaging that I needed to do and recombine things based on the ratio and so on, because any of these parameters here could be type parameters, or there could be something complicated that erases to the same thing as something else. But yeah, I would say that if I were to summarize everything, the complicated parts were all here in the method encoding. Yeah. So, yeah. There are more things and more features that were implemented. This is another one that I particularly like, because this is something that most of you probably haven't seen before. But window or document in JavaScript has a create element method. And that takes a string, and again, the return type of the method depends on the value of that string. So this is a TypeScript encoding for that, where this type parameter here, it has a type bound saying that the k extends key of, and then the name of a type. So key of this would be one of the keys, logically enough. So that's a string here. So then you substitute k with the string, and then this here on the right side is a type lookup in TypeScript. So you'll notice that normally we use these kind of brackets for type parameters in TypeScript. But here we have square brackets. So that means look up this key in a type. So the result is something like this. So again, we generate even more methods. I find it interesting because we end up with a lot of code because we have to expand whole classes of TypeScript features into Scala code. So we do that at generation time. And there are more features like this that is implemented. The most interesting one is type mappings with partial and omit and so on. It's really, really fancy. Yeah, question?
Does the generated code contribute to the bundle size?
No, it doesn't. All of this at least should be erased. So the only consequence of generating so much code is bytecode. Like the resulting jar file is going to be bigger. And I mentioned 7 million lines of code. This explains some of it. I think the density of TypeScript to Scala is something like 1 line of TypeScript is 1.5 to 2 lines of Scala because of these things. I think some things are certainly more compact as well, but this is not. This generates a lot of code. Yeah, cool. Okay, I have just enough time for one more, so I'll show you. Because another thing that we have in Scala.js is union type, and it's implemented in userland, which is a really cute hack, but it doesn't work well with the type system in terms of variance, subtyping, and stuff like that. So a union of A, B, and C doesn't have a relationship with the union of just A and B. In a sense, they're just different. And also, it has a lot of overhead for the Scala compiler if you have a very long union type, as you do. So one trick that I pulled was to rewrite certain type aliases of union types. You'll see one here, into inheritance, because one is equal to the other. There are some buts and ifs and don't do's to keep this sound, but in general, you can do that rewrite. So then we end up here. This union type becomes union interface. And yeah, we use inheritance to show the membership. So this is really cool in TypeScript that you can use unions as ad hoc ADTs. It's really powerful, and you can even get, if you use it right, you can get exhaustiveness checks from the compiler. So ad hoc ADTs is really powerful in TypeScript. So yeah, I just rewrote them to something that is closer to our ADTs without being it. Right, so this is also representative of the transformations that we do to the tree to massage it into something that is useful. There are a bunch more. I think I have more than 30 faces that each will do a translation like this. But this is one of the more invasive ones. Right. Yeah, still have a little bit of time, surprisingly, so let's continue on. There's also the case in TypeScript that you can have anonymous descriptions of objects. So this one here this is a function that returns an object with this structure. We do have that in Scala as well. They're called structural types, but they don't really work with Scala.js. So I invent names for them, starting with anon, and then a string from the members, from the contents of the interface. Yeah, and another thing that we can do is that we generate traits like these. This is also from the standard library. And this thing is newable, but it's a common trap in Scala to new traits because it's easy to cheap up type checking. I think it's been getting better, but people are not used to that. And it was one of the first reactions that I got to this whole thing, that why do I have to new things? I'm not used to that. So I also generate objects that will create this object, so you can have method syntax for creating them. And this is, of course, I mean, it's entirely obvious based on the definition of the trait. Yeah, I think that's what I had. Do you have any questions here? Yep. Yep. Yes. It is taken into account.
Once you can extend several types, right? But then it's not extensible.
Well, the original type definitions are not extensible from the Scala.js side anyway, if that's what you mean. Like, I fully agree that using a type union is extensible because it's ad hoc. You can do it at use site. But this is all derived from somebody else's code anyway. So you cannot extend that particular type union. If that answered the question, was it? Yes. Yeah. Yeah, from the back there.
I also have a question on the class unions. Did you consider using like with because then you could also have subclassing. So like if you had if the class was yes with no with true with B.
Yeah, and yeah, so the question was, did I consider using with? And I do, but those are for intersection types, which is the kind of opposite of union types. So that expresses we have both that and that. And TypeScript is one or the other. Did that answer the question? Great. Anybody else? Yeah, Eric?
So as part of the divide and conquer strategy, you go from one method to potentially many methods based on the parameter types.
Yes.
Do you ever have cases, though, where if you have some value that's known to be a union, how do you have a way of dispatching to the right implementation? Do you have like one that can accept that? Because having 6 overloads, what if I don't know if I've got string or null? I just know that I've got one or the other. How do you dispatch to the right implementation?
Right. Good question. So the first thing to know is that there is only one implementation. Right? So all these overloads, they point to the same thing. But if the method originally took a parameter of A or B, and I split them like this, and I have a value of A or B, it is true that it's now more inconvenient to pass it as a parameter. I have thought about keeping some of the originals around to allow that. For now, you would have to do a cast to make that work. Yeah, you.
Maybe a stupid question, but how would you now react to the designer asking you to kind of integrate this fancy design component in your code? How would you then solve this problem?
Now I would solve it by picking something off NPM and then find the type definition for it, and then set up the projects such that we do JavaScript bundling to produce the final artifact. So the process is essentially the same as it would be for a pure JavaScript or TypeScript project, with the additional constraint that you add the typings. Did that answer your question?
Yeah, but I thought, so like, okay, you're going to, I thought, okay, let's take that library and then generate the Scala.js from it and use that, or?
Yeah, so we are,
Just wondering.
I'm not sure if I got it, but I mean, the library is one thing that lives there, is maintained by somebody, right? And then these type definitions might be developed by a third party. So we just take the third party definitions and we rewrite those. So when we bundle the application together, we need both. We need our generated code based on the third party typings, and then we need the original library. Put them together, bundle it, boom. Right. Yeah, Adam?
The compiler itself, is that then published anywhere?
It will be published. It will be open sourced eventually. I'm slow to do it, and like there's some refactorings that I should do, but it will be pretty soon. Yep.
You mentioned that currently you have artifacts on release trade,
Mm-hmm.
but it's not scalable. So what's your plan for distribution?
It's a very good question, and I don't have a definite answer for it. One thing that was recommended to me was to use Jetpack. That is a service that can build things on demand, because most of the artifacts that I generate won't ever be used. And that's okay. So perhaps something like that could work. Or, you know, we would just need a terabyte of data on somebody's server. I don't really have that, but yeah, or Sonatype, who knows? I bet somebody would be impressed eventually. Anybody else? Last question? Okay, thank you then.